Hello students, this is the Digital Knowledge Irshad Academy with a new video of not a logic gate. Simplest of all logic gates belongs to a family of basic logic gates, that is AND gate, OR gate and NOT gate. NOT gate is the third gate which belongs to basic gates and very simple. Looking at the diagram before going to explanation, see that you have subscribed my channel and press bell icon for the next video to reach you. Looking at the circuit, we have a battery, a switch and a lamp. Switch is connected across lamp, or we can say battery, switch and lamp, they are in parallel. Now let us see that the switch is open or logic 0 condition. Open condition or off condition is the logic 0 condition. The current which flows from a negative side of the battery to lamp back to the positive terminal of the battery through the battery, and the circuit is complete, and the lamp is giving light, that is it is on and it gives a logic 1. When the switch is logic 0, the output is logic 1. When the input is logic 0, the output is 1. Now when the switch is in on condition, there is logic 1. When the switch is closed, the current flows from negative terminals through switch. Switch on means is a short, just a piece of wire, and through the switch it goes back to positive terminal of the battery, and the current does not flow through the lamp. As such, the lamp is off. Therefore, when the switch is closed, there is logic 1. The lamp is off, there is logic 0. This is the NOT gate with a single input, a single output, but the output is complemented, or the output is opposite. When it is logic 0, output is logic 1, and if we are giving logic 1, the output is the logic 0, and this is a input is complemented, or it is negation in the output. The symbol is an amplifier with an inverted bubble. The input is A, the output is A bar, or we'll read it, A input is equal to not A. We will read this as a not A and not A bar. The input A is complemented in the output, and we will read this as A is the input, the not A is the output. The circuit can be, this logic operation can be performed by using a common emitter amplifier. See that this is the common emitter amplifier. Q1 is a positive VCC through R1. RL is applied at the collector. See that we are applying a high voltage, there is positive 5 volt, there is a logic 1 at the input base. The Q1 is forward biased and Q1 starts conducting, and this positive VCC is shorted to ground through Q1, and we get in the output as 0 voltage, which is a low logic voltage. We are giving high level voltage, logic 1 voltage in the input, but we are getting logic 0 voltage in the output, or low level in the output. See that A is the input, and output is, the Boolean expression is Y is equal to not A. Going to common emitter amplifier once again, positive 5 volt, which is a logic 1 voltage or a high level voltage, is applied at the base of the NPN transistor Q1. It is forward biased, and when it is forward biased, this positive VCC through RL is shorted to ground, and the current is not flowing in the RL, and the output voltage is 0 voltage. We are applying logic 1 voltage, but we are getting logic 0 voltage, and if we apply logic 0 voltage, we'll get here the logic 1 voltage. Now, when this is reverse biased by applying a logic 0 voltage, Q1 is not conducting, then this positive 5 volt VCC is available in the output from here with respect to ground. Coming to the summary, output state is always opposite to the input state. A is the input, not A is the output. This state is opposite to input state. Gate has single input and single output. Output is inverted from the input as in common emitter amplifier circuit. Inversion function is also called negation. This process, the performance by this circuit is called as a negation. Input 0 is inverted to logic 1 at the output. NOT gate performs a complementation operation. It performs a complementation operation. Symbol for inversion is bar over the function to indicate opposite state. A bar means not A. This is most important. This is to be kept in mind, that we are not going to say A bar. We will read this as not A. A is the input, not A is the output. Bar represents the negation and is not a operation. Symbol for NOT gate is a small circle with amplifier. Bar is also called complement operator. This bar is called as complement operator, also called NOT operator or unary operator. Going over to the main points, is a NOT gate, simplest of all logic gates. A single switch, lamp and battery, they are all in parallel. Switch in open condition, lamp is glowing, and with the switch is open, mean off is a logic 0, output is 1. Why? Because the lamp is glowing. When the switch is closed, the battery is shorted, or we say that current finds an easy path through switch and back to the battery and does not flow through the lamp. When the switch is closed, logic 1, the output is a logic 0. See that one thing more to explain. When the current is flowing from negative side of the battery to the positive side is called electron current, and the conventional current is the current which was flowing from positive to the lamp back to the negative, and conventional current is current flows from positive terminal to negative terminal, and it is in the batteries, but the electron current will always flow from negative terminal to positive terminal. Symbol is a triangle or an amplifier with a bubble at the output. A is the input, A naught is the output, and is a complement of A. This is a CE amplifier, common emitter amplifier. When we are going to give a positive 5 volt, there is a logic 1 voltage, it is forward biased. The positive VCC is shorted to ground via conducting transistor Q1. Why? Because when the transistor is conducting, it is almost working as a switch or a small piece of wire with logic 0 voltage or a low level voltage applied at the base. This is reverse biased. The VCC is available at the output with respect to ground, and with the logic 0 input we are getting logic 1 output, the opposite of the input at the output. Summary already explained. That's all. Thank you very much. In the next video we'll study NAND gate.